Okay. Today was the session of 3D Max, but due to some emergency issues, faculty is not available. So today the session of structure modeling is taken. So Anandu, you can start the recording.
Okay.
Okay. So before start the session, let me introduce myself. I'm Seena. Here I'm working as HOD of Architecture Department, and I'm also a certified instructor of Autodesk. Okay, so today I'm going to take architecture modeling, sorry, structural modeling portion. So here you can see one PDF. Today I'm planning to create this 3D structure model based on this design data. So as we know that Revit is a BIM modeling tool. BIM is a building information modeling. So here you can see that here I use a 22 version of Revit. So Revit is a product of Autodesk. So now I'm going to create a new project. So here we can see that mainly we have two options. The first one is models and second one is the families. So now I'm going to create a 3D model. That's why I'm click on to the new option under the model category. So click here. So if you when you start a project in Revit or any other softwares, we need to choose a template. Okay, so for structural modeling, I'm going to choose structural analysis default metric template. That's a default template for structural modeling. So I'm going to choose the structural analysis default metric template. Then I'm going to open. So here I want to create a new project. That's why I choose create new project option. Then click on OK. Okay, so this is the interface of Revit. And here we have two levels and both normal floor plan levels and we have two analytical. This is actually for applying the loads in Revit. So first of all, I'm going to open the level 1 floor plan and set the unit before start the modeling and the centimeters. And okay, then back to our PDF. So here I've just planned to explain this model. So first of all, you can see that here we have multiple columns. This is actually the structural columns, custom placed columns. And under all the columns, we have pedestal. Okay, so the pedestal is the resting portion of column and what lower portion of the column, sorry, pedestal, we have two footings and one PCC. And we need to add these 1, 2, 3, 4 steps under each columns in ground floor, right? So in this slab top area, we need to add floor beam and yes, again we must add plinth beam in the plinth level and above this ground floor we have columns and also we have slab and this is actually the stair room. So this is the basic structural model. So we can create this model based on our structural design data. And for that, we have some calculations. We have some model details like, so first of all, I'm going to open the column layout. So this is the first PDF, our first sheet in our PDF. So here you can see that some columns is here and we have different type of modeling method to create this structural model. So we can directly create from the structural template, and second one is that we can import architecture or CAD drawings into Revit, and then we can develop that 2D drawing into 3D. And third one is that we can simply link architecture model. Then we can add some or we can replace some architecture column to structure, and we can use some data elements like levels, grids from the architecture reference model, and we can simply convert that architecture model into structural. So that is the different methods to create 3D models. So first of all, here I'm going to choose an architecture 2D drawing. I have a 2D CAD drawing. So I'm planning to import this 2D drawing into Revit and for create the structural 3D. So first of all, I'm going to open the Revit. So here you can see that this is the basic floor plan. So first of all, I want to add some levels. So here we have two, by default, we have two levels. The level difference is 3 meter or 300 centimeters. So first of all, we need to set the levels according to this design. So here you can see that this is the design. And zero level is the ground level. Above and we need to create two levels just above and below of the ground level. The level difference is 22.5. That is for plinth level top and bottom. So we need to place plinth beam in between these two levels. Okay. And from the plinth level top to beam bottom, we need to create a 330 that is level difference is 330, and the level difference from slab top to beam bottom, that is 35 centimeter, and again the thickness of slab is 50, that is from slab top level. So this is the details of ground floor plan and the ground level, and go to the substructure of this building. So we need to create a level 4 pedestal. Okay, so here we use the height of the pedestal is 80 centimeter. And actually, this is according to the height of the building. Okay, so maybe it will be changed up to 1 meter. That is, I already said, that is according to the height of the building. And here you can see that the 30 centimeters the thickness of first footing, and 40 is for the second, and 10 is for the PCC. So these are the different size of the footings. And go to the first floor. Here also the floor height is 330, and the beam slab thickness is 15 centimeter, and beam thickness, that means depth of the beam is 35 centimeter. And go to the third floor or the roof level. So the height of the floor is 300 centimeter here. So this is the level calculations. So I'm going to add this levels into the Revit. Okay, so first of all, I'm consider the level 1 is the ground level. Okay, so that is the 0 level. And I'm planning to convert level 2 as a plinth level top. As you know, the total thickness of plinth beam is 45 centimeter. That's why we need to place the plinth beam in between plinth level top and bottom. That's why. So level 2 I plan to consider is a plinth level top. So the thickness of, or the level difference of these two levels is 22.5. That is half of 45. And then again, we need to create a new level. For create a new level, go to structural tab in Revit. So here we need to choose structural datum elements. So that's why go to datum elements, datum panel. Here we can see that level is here. Actually, we can only place levels in elevations. When I go to floor plan, we can't see that. That's disabled. Okay, when I open the elevation, we can see the level. The level is active. We can place a level in elevation only, but we can place a grid in both elevations and sections, floor plans, etc. So I'm going to choose the level, and here I choose the pick line option. And this is actually for, we can choose reference for creating new levels. And the one condition is we must add offset value. Otherwise, we can't. So the offset value is the level difference from plinth level top to bottom. Plinth level top to, ground level to plinth level bottom is 22.5. The offset value is 22.5. I'm going to place below the ground level. Okay. So again, 330 is the level difference from plinth level top to slab top. You can see that. So 330 is up to slab top, ST level. So 330, select this level, and 35 is the depth of the beam. So that's why we need to choose level 4 as a reference for creating the beam bottom. And 15 is the thickness of slab. Place like this. this is, I already said that this is not the proper calculation, or so this is actually I just create from the what created design data. Okay, so this is actually completely modeling. Okay, not in the designing. So then I want to rename this levels, and this one is the middle of this level is called ground level. The notation is GL, and this is for PLT, plinth level top, and this one is for plinth level bottom. This is for slab top ST, and this is for slab bottom. SB, slab bottom, and this one is for beam bottom, BB. Okay, so this is the level names. So the next one here you can see that some text is overlapped. So that's why I'm going to choose actually use common technique. Here you can see that one elbow option is here. So we can add elbow, and again add elbow here also. Okay, now I can see that. And we have another option is just select this level, and here we have an option. This checkbox is to control the visibility of elevation bubble. So when I turn off this option, the elevation bubble is off in this right side, and go to the left side of the elevation, we can turn on here like this. Okay, so another technique. And also here I am going to add. Okay, then the next step is we want to add levels in substructure. And as you know that the height of the pedestal, I already said that here the height of the pedestal is 80 centimeter, and that is from plinth level bottom. Going to add a new level. The offset value is 80 centimeter, and place that 18 below the plinth level top, sorry, bottom. Align like this, add an elbow, and rename. The name is PD, PD for pedestal. And again, in this direction, 30 and 40, 10. 30, 40, 10. Level, decline, value 30. And this is for second footing, that is 40. Then last one is for PCC. Okay. So then again rename. Align like this. And again, I'm going to rename this view. And this is a pedestal. And okay, so then this is plinth level bottom, this is pedestal, and this one is footing 1. And next one is F2, footing 2. F is enough. F, then F1. This is for PCC. So this is the way to create levels in Revit. So the next one is after create the levels, we can go to floor plans for adding the columns. So before adding the columns, I already said that we have multiple techniques for create structural model from the reference, and we can directly create from structural template, and we can manually place columns and beams in between the column. And the second one is we can simply import the CAD drawing into Revit, and we can develop the CAD drawing into Revit structural 3D model. And third one is we can link architecture or another Revit 3D model into structural template, and we can sometimes we can take copy from the link, and we can replace some elements from the link, and so all those things it's possible in Revit. So here I'm going to choose the second technique, that is I'm going to import a CAD drawing into Revit. Then I'm going to place structural elements based on the CAD drawing, right? So for that, I'm going to open the ground level. I'm planning to place the floor plan into this ground level view. Okay, so this is the drawing Revit structure workbook in import. That is the drawing for structural modeling. That is AutoCAD drawing. And here I'm going to import that drawing into Revit. For that, go to Insert tab. Here we have some insert options and link option, import options, and import what family library option is here. So here I want to import the CAD drawing. That's why I choose import CAD. Okay. Then choose that file that is in desktop and lives folder structure. So this is the drawing. And here I'm going to choose the positioning manual center. I want to place this inside the elevation bubble. Sorry, elevation bubble. That's why I choose this option and place at ground level, and import unit is auto dictate and open. So you can see that this is the drawing. I'm going to place this inside this 4 bubble. And the first one is after import the drawing into the CAD, so Revit. So first of all, you must take a dimension in the CAD drawing, and we make sure the unit is correct. Okay. So go to modify. Here we have aligned dimension option. So we need to place a aligned dimension in between this beams. Here we can see that this is for floor beam. So that is 30 by 35. That is the text in the CAD drawing. So 30 is the width, 35 is the depth. Here you can see that this is the width. That's why I'm going to take the dimension. So that is 30. That means this unit of this CAD drawing is also an important scale of this CAD drawing is also centimeter. Okay, now the drawing is correct. So the next step is we need to place the structural elements into the into this view. Okay, so we already add some levels in our project. So that is actually level is for rough. It's actually a reference. When we add a levels in the elevation, we can take floor plans from the each level. So that is the use or advantage of levels, and it represents the height of the building. And if you want to add some width reference or something like you want to place some reference in floor plans, so we must choose the grid lines. So that is also a part of datum element. So here we can see that some of the grid line is here. I want to place the grid lines. So I need to use this reference for place the grid line, right? So choose the grid option here under the datum panel in structural tab. Choose the pick line. I already said that this is for reference. We have 2 methods to place this reference pick line option. So the first one is we must once we have no reference for create add this grid or levels, we must or we want to choose the pick line for adding the same element. So we must add the offset value. And the second one is when we choose the pick line for creating the create the elements, we must have a reference, or we must have a model reference. Here you can see that some level is grid line is here. So I'm plan to take this line as a reference. Okay, so choose the pick line. No need to add the offset value. Here I'm going to pick this grid line. Here you can see that when I pick this line, we can see the one is 1, 2, 3, 4. 4 grid line is placed. Okay, so then I want to add some horizontal grids, but the head of the grid is now it's a alphabets. Here you can see that I just add some numeric grid. So in the horizontal direction, I want to change the text of the grid. So first of all, I'm going to add a grid line, and now you can see that automatically the number after 4 is 5. So just escape and select the grid and click onto the grid head and change into A. Okay, so then I'm going to create the similar element. Okay, select that element, and here we have an option to create the similar. Under the modify tab, create panel, you can see that create similar. Okay, choose that option for create the similar element. Again, choose the pick line and select this grid line. You can see that B and C is here, D, E, F, G. And suppose the head of the Z is in right side. That's why I'm turn off and turn on here. So this is the way to create the grid line. I just change the position. You can see that. Now this is the structural grid lines. Okay. Okay. So the next step is we want to add structural columns into this view. So go to our design. Okay, so you can see that the size of this column is 30 by 45. So that is 30 length and 45 is the width. Okay, so we need to place this column from plinth level bottom to slab top. Okay, I just open as elevation. I want to place column from plinth level bottom, this level to slab top. Okay, so column is a vertical element. Go to plinth level bottom. Here we can see the reference. So I want to place columns in this area, green color area. So that is the position. So for that, first step is a column is a model element. So that's why we want to insert a column with a size 30 by 45. And here you can see that go to structure tab under the structure panel. You can see the column. So this is the structural column. Choose the structural column. Here, by default, we can see one I-shaped column. So this is called universal column. This is a steel column. Here we want to choose concrete column, right? So just drop down this option. So this is called type selector. We can see the multiple type, okay, of the same element. So here you can see that the universal column is steel column and M concrete rectangular column is the rectangular column. Choose one type and go to edit type. In Revit, you have three different type of families. All the elements are in the Revit. All the elements are families, but we can classify that all the families in three main divisions. The first one is system families. Okay. System families is the example of system families in Revit is wall, floor, ceiling, stair. All those things are example of system families. When I install this software, that some of the type is already installed with the software. That is called a system family. Okay. So and the second type of family is called a loadable family. Okay. So the file format of loadable family is .rfa. The file format of normal Revit project is .rvt. Okay. .rvt means Revit. .rfa means what? Revit family. That is another file. Okay. We can save in our local drive, and Autodesk provide different type of families, libraries, all those available in our software. So that is the second type of family. That's called a loadable family. When we create a loadable family, we must choose a separate template for create the families according to the character of that element. If suppose you want to create a door as a family, you must choose a template for create the door family. So that is maybe that is a metric door template. Metric door is the template for create the door, and we have a template for window, columns, beams. All the templates are available in our local drive. So after open the template, family template, then we can create the family. When we save that family, the file format of family is .rfa. So we can import that .rfa family files into our project, and we can use that families in multiple project. Okay, so that is the use of what? Loadable family. So we can use a single family in multiple project. Okay, so that is the main advantage. Suppose if you are a civil engineer, or if you are a structural engineer or some architect, so you are planned to use Revit. Suppose you are under in an organization. The organization have this some specific families. Okay, so they only use that families in their project. Okay, so we can create that family. So that is the loadable family. And the third one is the in place family. So in place family is actually, so we can create some in place families in our project. That is we use the in place family only for a particular project. We can't share that. The example for in place family is the sunshade and some of these shades projections in our project. So we can add that type of shapes as a family, in place family. So we just create that family inside a project. We can't share that. Okay, that is the main difference between laudable family and in place family. So here you can see that and column is in a laudable family, and we can use and we can create columns as per our requirement. So and we can create some, suppose you want to create an L-shaped column, that is also possible. Okay, so we have a template for create the structural columns. So that is also possible in Revit. Okay, so here I choose what rectangular column, that is the laudable family. So that's why we must take a duplicate. So when we use a system family or a laudable family, you must take a duplicate copy for edit that one. Otherwise, the core or the main element will be changed. We can't use that default element in another purpose. So that's why we must take a copy, then edit the element. Okay. So follow the step always when you use Revit. Okay. So go to duplicate option here. So that is duplicate is for taking the copy of the same element. So here we must add a name. For better way, what is the title of the column? We can add this name as a tag or the type name. So here you can see for when you are take or when you are add tags in your column. So we must add tag as C30 by 45. That's why we can add this C30 by 45 name as a type name of the column you want to place in your project. So here I'm going to add the name is C30 by 45 as a name of the column, and breadth and height of the column is also 35. So that's enough. No problem. And go to OK. So here we successfully create a column type. So the second step is we want to place the column into our project, right? So after enable a tool, we can see one green color panel is available below the ribbon. That is called the option bar, right? So I want to place, I already said column is a vertical element. So I want to place this column from where? Plinth level bottom to slab top. Okay, so that's why we need to change the this depth to height. So then go to add the level. Okay, that means top level of the column. So that is slab top. Then I'm going to place, you can see that 250 height of the column is 250. Then I'm going to place the column here. And then we can't place the exact position. After place the column, we can align with our drawing, reference drawing. So here you can see that the alignment of the column is different. So you want to change the position or you want to rotate the column in a single click. We can use the space button in our keyboard. Just click the space. You can see that. It will change like this. Place in this position. And the next step is you can see that all the column is in the wrong place. We need to align. So go to modify. Under the modify panel, we have different type of modify tools. And in the modify panel, the upper left corner of the modify panel, we can see the align tool. Just click on to the align. And I want to align this column into this point, right? So the step for align the for manage the align tool is enable the tool, and second one is select the reference. Okay, and select the element you want to change. Okay, select the reference and select the model element. So this is the way to use the align tool. Select the reference line and select the model element. Repeat the step and apply this step in all the columns. We can use this align tool in during our modeling time. Suppose some of the element is not placed in the proper position, and you know about the what reference of that element, we can use the align tool. And suppose the align is not supported in that element, we can use the another modeling, so modified tool like move or copy. So that is available. So this is the way to align our model. Okay, so we have successfully placed the columns in our project. So if you want to see the 3D view of the Revit, go to View tab. Under the Create panel, we can see one 3D view is here. Drop down the 3D view, and under the 3D view option, we have default 3D view option. Just click on to the default 3D view. So here you can see the column is here. And now this visibility of the visual style of this view is what wireframe. Suppose you want to change the visual style, this is called the view control toolbar, that is bottom of the view. And in the third tool from the left side, that is called visual style, and choose the realistic. Okay, so this is the way to create columns. And the next step is we want to place footings below the column. And for pedestal is also what a vertical component. So here again, I choose the plinth level bottom. That is a level for create the pedestal. And so before going to create the pedestal and footings, so we need to know about the dimensions of that element. And in the workbook, we have, so this is the details of pedestal. And we can see that, so the middle of the center of this footing is column. You can see the tag. So this is the C30/45. That is the column. So this highlighted black line is pedestal. The tag of the pedestal is PD. Okay, PD. What's the name? PD 40 into 55 into 80. Actually, 80 is the height of the pedestal, right? So and 40 and 45 is length and width, right? And that is the pedestal. And here I'm going to place the pedestal below the what column. So pedestal is the resting point of the resting element of columns. So for adding the pedestal, go to structure tab under the foundation. Here I'm going to choose the isolated foundation. So this is actually a rectangular box. Here we need to create the pedestal type. Go to edit type option. So here you can see that. So this here we have only the one type with two different sizes. So suppose you want to change the size or you want to create a new type from this system family, go to edit type. So this is actually for editing that particular element. And I already said that when we plan to edit an element in Revit, we must take a copy, right? So click on to the duplicate option and take a copy and go to the our workbook. We can see that name is what PD 40 into 45 into 80. Just follow the name. The name is PD 40 into 55 into 80. So the next step is we must add these values into the footings for change the parameters, right? Here we have foundation thickness, width and length. So foundation thickness is the height of that element. Okay, foundation thickness, the height parameter. Here the height of the pedestal is 80. And width I just add 40 and length is 55. So this is the way to create a new type. Okay, foundation thickness is an elevation or the height parameter, that is for height, and width is width and length, as you know that. Click on OK. Then you can see that pedestal is here. I'm going to place the pedestal in middle of the column. After place the column, we can see the center snap that is available. After place the column. Okay, just place. You can see that the placement level is plinth level bottom. Just place the pedestal in plinth level bottom. That is the top level of the pedestal. Pedestal. Okay. So foundation is part of substructure. That's why it will create in the negative direction. So that's why you want to choose the top level for create the footings as a reference. the top level of the pedestal is plinth level bottom. That's why choose the plinth level bottom as the reference level. Just place like this. And again, here also I want to place and just click onto the space bar in keyboard for change the direction, right? Just place like this. And again, I want to choose create footing, first footing with the size what? So this is the second element. This is the second element. You can see the name of that element, that is F70 into 85 into 30. That is the name. 70 into 85 into 30. Go to Revit and go to edit type. Here also we need to create a new type. The name is F70 into 85 into 30. 30 is the foundation thickness. 30 is the foundation. And this is 70. And this one is 85. Click on OK. So next, this is the first footing. The top of the first footing is what? Pedestal, right? Go to south elevation. Here we place the pedestal here. From which level? Plinth level. Bottom, right? And I want to place F in between these two level, F1, F1, F1. So the top of the top of this footing is pedestal. So that's why choose the pedestal as a reference level, then place here. Okay. So then again take a copy, and the next one is F1. This is the name F1, and this is the third one. This is column. This one is pedestal. This one is F, and this one is F1. 100 into 115 into 40 is the value, right? By F1, 100 into 115 into 40. 40 is the foundation thickness or height. 40, 100, length is 115. Okay. Then place where? Choose the F level. Place here. Here also. And again, go to edit type, take a duplicate. And the next one is what? PCC, right? The name of PCC, 120 into 135 into 10. 10 is the foundation thickness. PCC, 120 into 115 into 10. Add the parameters in the dimensions. 10, 120 and 135. Okay. Okay, then I'm going to place in F1. So open the 3D view, we can see that. So here we have a short key for enable the 3D view, that is in the title bar. Under the QAT, this is called QAT. QAT means what? Quick Access Toolbar. Okay, in the Quick Access Toolbar, we have a tool. This is called a tool of a small building. So that is for default 3D view. Just click and we can open. Here we can see that this is pedestal and this one is F and this one is F1. This is PCC. I want to place these elements from pedestal to PCC in all the columns, right? Go to plinth level. I just open the plinth level bottom. Then I'm planning to copy and paste the same element in bottom of all the columns, right? Just I'm going to select the elements and I want to add a PCC into this selection. Just hold the control button, select the PCC, and I want to exclude the column from this selection. Just hold the shift button and exclude like this. Okay, then here I'm going to enable the copy option. That is also under the modify. Choose the copy option to enable the multiple. No need to turn on the constraint, otherwise we can't place in this inclined direction. So just select this this point as a reference. What? Bottom left corner of the column. and place here like this. Okay, so this is the way to place footings. Just open the 3D view, we can see that. Okay, so this is the way to create columns, pedestal, footings. And the next step is we want to place beam. Okay, so we want to add plinth beam and open the PDF. We have data for placing the plinth beam. Okay, so this is the drawing for placing the plinth beam, and the size of the plinth beam is 40 by 45. 40 is the width, 45 is the depth of the beam. We want to place the beam in between plinth level top and bottom. Half of the beam must be in the under the ground level. Okay, so I'm going to place a plinth beam in our project. Open the top level of the beam. So just open the south. The top level of the beam is what? Plinth level top, right? I just opened the plinth level top, PLT, from the structural plans in the project browser. Here I can see the reference also. Just place the plinth beam in outer boundary of the building and just add in between the stair room. Okay, first of all, create a type for structural plinth beam. The type name is what? PB 40 by 45. Okay, so go to structure tab. Here we have beam option. Okay, or structural framing is called beam. Choose the structural framing or beam. So here also we can see that UB, universal beam. That is what? Steel type beam. But here I want concrete beam. Just click on to the type selector. We have multiple styles is here. Choose one type and go to edit type, duplicate. That is plinth beam 40 by 45, right? Breadth is 40 and the height is what? 45. Then okay. Then I'm going to place the beams from the center of the column to another column and place like this. After place the column beams, we can align and we can correct in corners. Okay, so then open the 3D view. Just go to this corner. Here you can see some errors. Okay, you can see that the position of beam is wrong. We can see the column that is visible. So again, we need to align, right? Go to plinth level, top level, here. Top. Here we can see that this is not aligned properly. Go to modify, choose the align tool. First of all, select the reference. This is the reference and select the element. This is the way to correct the corners. Suppose maybe here also. have some errors. No, that's correct. Open the 3D view. Check all the corners. Must be covered properly. Okay, now you can see that when we consider this corner, you can see that column is inside of the beam. Okay. So this is the way to create plinth beam. And the next step is I want to place what? Floor beam. Okay, open the south elevation. We can see that the beam is in between what? Plinth level top to plinth level here, plinth level bottom. So the next one is I want to place what? Floor beam in between this slab top and beam bottom. The depth of the beam is 35. And go to our PDF. So here you can see that floor beam FB 30 by 35. And here we have a concealed beam, C beam. So with size is 30 by 12 is not correct. 30 by 50. It must the depth of the concealed beam must be the size of the or the thickness of the slab. Okay, that will be is equal to thickness of the slab. So here we add level 15 for the slab thickness. That's why the size or the depth of the concealed beam must be 50. So actually the concealed beam we can place inside the slab. We can't see the projection or the outside projection. We can't see that. So the difference between when we add a concealed beam in a slab, so the difference is we can add normal rebar in our slab according to the L by B ratio, and L by B and then what is the concealed beam inside the slab? We must add same detailing of beams in the concealed beam. So that is the main difference. Okay, so then back to the size of the floor beam is 30 by 35. Okay, then back to our project. So here I am going to open this ST level. So place that element. So here I can't see the reference or I can't see the CAD reference. In Revit, so you want to see any reference from any of the floor plans, we can use a technique. So that is actually called a range base level. And that is under the underlay group parameter in the view property. So this is the structural plan. You can see that. So now we are in the view property of the structural plan. So in the view property, we can see that underlay group parameter, and under the underlay group parameter, we can see the range base level. Set the range base level in GL because plan is in the GL. Okay, so now I can see the reference, right? You can go to structure, choose the beam, and again go to edit type and duplicate. The name is FB, what 30 by 35, right? Then okay. So it's 30 and the height is 35. And I'm going to place the here, beam here. I just only add beam in the outer boundary because we have no more time for the documentation. That's why we can add the same element inside the room also. I mean, inside the building. Then here again, we need to align, modify, choose the align tool. So this is the way to create the floor beam. Open the 3D view, you can see that. Okay, so if you want to add a concealed beam, see here we have, this is two concealed beam. I just add a similar element of this beam from this point to this point for adding the concealed beam. Okay, for create the concealed beam, go to edit type and duplicate PB what 30 by 50. 35 is the normal depth. 15 is the thickness of what slab. Then draw here. Align. Okay. On the 3D view, you can see the difference here. You can see that top of the beam is same, and go to the bottom view. For rotate the 3D view, just hold the scroll shift button and scroll button at a time, then we can rotate. You can see that the depth is different. And the next one is you want to add a slab inside this view and go to ST level. I just add a slab in these two rooms. Go to structure, and here we have floor option. So here we must use the structural floor, otherwise we can't add span direction like one way or two way. So create a, after just choose the structural floor structure, go to edit type because we need to change the type, right? Duplicate, and the name is slab 15 is the name. And okay, go to structure edit, otherwise we can't what change the thickness. So 15 and okay, then I'm going to add a slab like this. So it must be closed loop. That is a condition. So first of all, I'm just add a slab inside this four columns and just finish. Here you can see that this is the span direction. Select the span direction and change to two-way. So this is the way to add. Go to 3D view. You can see that. Okay. So I hope you understand the modeling technique. And this is the way to model our structure according to the design data. So this is the modeling data for create the 3D models. This is only I only what cover the modeling area of the 3D of the structure, and after complete the model, so we can analyze the model. Then we'll get the can see the what rebar calculation. By using the rebar calculation, we can add rebars or steels inside the beam. So that is actually you can here I just so that so this is the rebar you can place inside the column, and also beam slab also. This is the beam detailing and this is the slab detailing, and here we have a stair detailing. This is also possible in Revit. So for adding, I'll show one more thing that is for adding the tag. Suppose you want to create a column layout, just open it, view. That view must contain columns. So here I choose plinth level top. Here we have column. Okay. So the first step is select all the and so I want to set the column view same as in the PDF. In the column view, column layout only have what columns, grid lines, and the column tag. And in between we need to add, we can add dimensions. So for that we must set the view. So that's why I want to hide the beam. Select one beam and right click, hide in view category. Now all the beam is hide, and select one footing, hide, so right click, hide in view. I want to add the footing category also. And again, I want to hide the CAD file. Select the CAD file and right click, hide in view element. And now we can see only grid lines, columns. This is the way to create the set the views. Then next step is we want to add some column what tags. For adding the tag, go to annotate tab. Here we have tag all option. Just turn on the tag all. Here we have structural column tag. Just turn on the structural column tag, apply, okay. Now we can see that. Because the type name of the column is C30 by 45. That's why it's visible in the tag position. So this is the way to create the structural model. So by using the same method, we can create first floor, second floor, and also we can add stair. So for adding a stair in our view, stair is a part of structure architecture. That's why go to architecture tab, under the circulation panel we have stair. Choose the stair, and in the type selector, we have multiple type is available. Actually, the assembled stair type is a wooden stair. That's why we can't use the wooden stair in our structural model. We have two another type, that is cast in place stair and precast stair. I just plan to use the monolithic cast in place stair. Then I just create like this, and just select first flight, and we can change the position by using the up and down control button in our keyboard, then finish. Okay, so when I open the 3D view, maybe we can't see the 3D of the stair, because I already said that stair is a part of what? Architecture. This is the structural template. We have some view what settings. For unhide an element in our view, we have a tool that is called visibility graphics. Okay, so visibility graphics we can see under the property browser. So this is called visibility graphics, or VG is the short key for enable the visibility graphics. And actually stair is a part under the model category, and go to stair. Here we can see that stair is turned off. Just turn on the visibility. So this is the visibility of the stair. Apply OK. And we can see the stair. So this is the way to create the structure model. So I just take the structure model in a short period of time. I hope you understand. Anyone have any doubt? Otherwise, I can wind up. Okay, so thank you, Paul, for your comment. So, so let me wind up today's session. So thank you.